Part 2, partial fraction decomposition, repeated linear factors. If the rational function that we're trying to decompose has a denominator with linear factors, but some of those factors are repeated, then we're going to have a separate fraction, a separate partial fraction for each time that it is repeated. So for example, so you can see what that means, if I have x squared plus 4x plus 6 over x plus 1 cubed, x plus 1 is linear, but it's repeated. So I'm going to break this into 3 fractions because it's repeated 3 times. It's to the 3rd power. So the first fraction will be a over x plus 1, the second fraction b over x plus 1 squared, and the third fraction c over x plus 1 cubed. A, b, and c are still going to be constants, so we can break this up into those 3 fractions. Now, it's possible that a or b will be equal to 0. That can happen, and then that fraction will be gone. But it's also possible we'll need both the a, b, and then the c also. And if we do this in this case, we get 1 over x plus 1 plus 2 over x plus 1 squared plus 3 over x plus 1 cubed. Let's try one. So here we have 5x squared plus 17x plus 26 over x plus 3 squared and x minus 1. Notice the factors in the denominator are all linear, but the x plus 3 is repeated. So to set up the partial fraction decomposition, I have 5x squared plus 17x plus 26 over x plus 3 squared times x minus 1 equals a over x plus 3 plus b over x plus 3 squared plus c over x minus 1. And x minus 1 is not repeated, so we're done with this. We have these 3 partial fractions. We need to find the a, b, and c so that this left side of the equal sign will be equal to the right side. Again, the first step, clear the fraction. So I'm going to multiply both sides by x plus 3 squared times x minus 1. So on the left side now I have 5x squared plus 17x plus 26. And then on the right side with the a, one of the x plus 3's cancel. So I'm left with the other x plus 3 and the x minus 1. With the b, x plus 3 squared cancels, so I'm just left with x minus 1. And with the c, the x minus 1 cancels, and I have x plus 3 squared. Once we've cleared the fraction, so every time I plug in a different value for x, I'm going to come back to this right here. So the first value, I'm going to pick 1, because if I substitute x equals 1, then my a and b terms will both be multiplied by 0, and they will disappear. So I'm going to let x be 1. Then the left side, I have 5 times 1 squared plus 17 times 1 plus 26 equals a times 4 times 0 plus b times 0 plus c times 4 squared. So everywhere I had an x, I substituted a 1. Now that left side is 48, and the right side, the a is 0, the b part 0. I'm left with 16c. Divide both sides by 16, and I get c equals 3. So I know the c is 3. Then I'm going to go back to the start equation and pick a different value for x. This time I'm going to pick negative 3, because negative 3 makes the x plus 3 factors equal to 0. So on the left side, I have 5 times negative 3 squared plus 17 times negative 3 plus 26 equals a times 0 plus b times negative 3 minus 1 is negative 4 plus c times 0. So the a and c terms are gone. On the left side, if I multiply and add there, I get 20. And on the right side, I have negative 4b. Divide both sides by negative 4, and I get b is negative 5. Okay, I found b, I found c. I still need to find a. There's not any other convenient values for x, so there's no other values for x that will make one of those factors equal to 0. So what I'm going to do instead, I'm going to go back to that start equation, and I'm going to replace the c with 3 and the b with negative 5. So I have 5x squared plus 17x plus 26 equals a times x plus 3 times x minus 1 plus, but b we already said was negative 5. So negative 5 times x minus 1 plus c, which we said was 3, times x plus 3 squared. So I found the b and c. I substituted those into that start equation, And now I'm just going to pick a different value for x. I want this to be true. I want the left side equal to the right side, no matter what x is. So I'm going to let x be 0. 0 is a really convenient number. So if I haven't used 0, I'm definitely going to use 0. Then on the left side, I have 0 plus 0 plus 26. On the right side, I have a times 3 times negative 1 minus 5 times negative 1 plus 3 times 3 squared. Simplifying, I have 26 equals negative 3a plus 5 plus 27. So negative 6 equals negative 3a, and a equals 2. All right, I found a, b, and c. So my partial fraction decomposition is 2 over x plus 3. b is negative 5, so minus 5 over x plus 3 squared. And then c is 3, so I have plus 3 over x minus 1.